Welcome to lesson 1.2, when we're going to discuss SI area. Remember, SI stands for System International, or International System of Units. We're going to talk about what area is and how it relates to length, discuss what the SI units for area are, and that's actually all we're going to do in this video. Anywho, I want you to take out a blank piece of paper and determine how many of your thumbprints it would take to cover it. So go ahead and pause it and do that. Alright, so there's no right or wrong answer, as long as you did the activity. So when I did it, mine, you can put whatever yours is here, mine was 156 thumbprints. And what I did, you could have did all sorts of things. So one thing you could have did, well, that's a great rectangle, you could have just went and did thumbprint here, 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 until your entire page was covered. But as mathematicians, we try to be as lazy as possible. So what I did is I first figured out how many thumbprints it would take to go this way, and then I did how many thumbprints it would take to go this way. So for me, it was 12 this way and 13 this way. And then I went 12 times 13, and I got 156. I know what you're thinking, what does this have anything to do with math? Well, what we did in its most basic form was area. Area can be, well, it could even be in thumbprints. But the definition is the measure of a 2D surface. So we measured it in thumbprints. But typically, it's measured in square units. So, talking about square units and area, what is the area of this rectangle? A couple ways you could do this. You could just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my area, I know just from counting, has to be 12. But that's not the only way we could do this. We could also say, hey, there's 1, 2, 3, 4. I guess we'd call it the width, and 1, 2, 3. I could also say my area is length times width. So my area is 4 times 3, and that equals 12. 12 what? I don't know. We're just going to say square units. All right. So remember this, okay? Because this formula is going to come in handy, and it is the most basic formula for area, and we use it for all other area calculations. All right. Let's do one more like this. And remember, you can pause and do these on your own first, okay? So what's the area of this square? Again, I could count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know just from counting that my area is 9. Now we could also say, hey, this is 3 by 3. So I know that the area of any rectangle, so I'm just going to draw a rectangle so I know what shape I'm talking about, is length times width. And my length was 3 and my width was 3. So my area equals 9. But wait, a square is a special rectangle. I'm just going to switch colors. The area of a square is a terrible square. We said the length and width are the same in a square because it's special. So we could say the area is the side length squared. Alright, so my area is 3 squared. Remember, anything squared is just that thing times itself. So that's the same as saying 3 times 3, or my area is 9. So that's another formula. That the area of a square is the side length squared. All right, now those squares, we didn't know how big they were. In real life, we're going to want something a little bit more specific. So when we're measuring area with SI units, we use these here. So the first one is a millimeter squared, and that is a tiny little square that has a length of 1 millimeter and a width of 1 millimeter. Now this is very, very small. It's about, that square there is actually probably too big. It's probably closer to about that big. So we use these for measuring itty bitty things. All right. Some things we talked about last semester. You can measure bugs with them. We were saying that a pen point is about the same. Yeah, so anything that's very, very small. Oops. Now the next one that's a little bit bigger is a centimeter squared. A little bit bigger. And as you may have guessed, the length is 1 centimeter and the width is 1 centimeter. All right, so that square is about the size of, your pinky fingernail. About. And we use it for measuring, well, things that are bigger than bugs and pen points, but still relatively small objects. So we'll use these for things like my iPhone screen. And, I don't know, maybe a piece of paper, depending on how big it is. All right, so normal size things. And the last one we're going to talk about right now is a meter squared. And this is a much bigger square. I can't even draw it. It's a little bit smaller than the smartboard. So it is a square that has a length of 1 meter and a width of 1 meter. All right, and we use these for measuring big things. So I said it was about the same as a smartboard. Or maybe a table. We use this for measuring big areas, like maybe your backyard or flooring in your house, stuff like that. So I want you to try this practice question on your own, and then watch my solution and see if we did the same thing. All right? So a Canadian flag on a post office wall is 64 centimeters by 32 centimeters. What is the area in square centimeters and square meters? So I am going to do the square centimeters part first. So let's just, all right, there's my Canadian flag. And it is 64 centimeters by 32 centimeters. So to figure out my area in square centimeters, I'm just going to use my formula for a rectangle. It's length times width. My length was 64, and my width was 32. And when I multiply 64 times 32, my area will be 2,048. That is in centimeters squared. Now the reason we know it's in centimeters squared is because these two were in centimeters. All right, so part one of the question's done. Switch colors. Now, I want to know what this is in square meters as well. So we can do a couple things here. So method 1. Sorry, that was terrible writing. All right. First thing way we could do this is we could change these two numbers into meters. So let's do that way first. So here's my flag. Now I'm going to change 32 centimeters. I'm going to use a skeleton equation. All right, so from the question is 32, and I know that 1 meter is 100 centimeters. That's from my formula sheet, or if you have it memorized. So 100 goes here. And since I'm changing into a bigger unit, my number is going to get smaller. So 32 divided by 100, that'll give me 0.32 meters. So there's my width, 0.32. All right, same thing for my length. It's going to be 64 divided by 100. That's going to give me 0.64 meters. There's my length. Now, my area, same formula as before, length times width. It's going to be 0.64 times 0.32. Whoops. Now that is going to give me an answer of 0.2048 meters squared. Alright, but I said there's more than one way of doing this, as there always is in math. So I'm going to switch colors again. Now, from our formula sheet, you can see that 1 meter squared is the same thing as 10,000 centimeters squared. Alright, so we can just convert this 2048 centimeters squared straight into meters squared. So I'm going to set up another skeleton equation. Alright, so in our first blank is from our question. So that was our 2048. Our second blank, that's from our formula sheet. 10,000. 1, 2, 3. Alright. And now, since we're switching, so this is in centimeters squared, and I want to switch to meters squared. I'm switching to a bigger unit, so my number needs to get smaller. That means we divide. So 2048 divided by 10,000. That's going to give us 0.2048 meters squared. Hey, look at that, same answer. Sweet. So now what I want you to do is try the next few practice questions. Make sure you ask me if you have questions, and make sure to check your answers as well. Thanks.